Okay, so Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan nama saya Cecilia Potto dengan NIM E1E124079 program studi teknik informatika, and today I will represent my presentation for LinkedIn list data structure and algorithm with Python. Data structure algoritma dengan Python. Okay, so for the overview itu ada introduction which is pendahuluan, and then berbagai jenis LinkedIn, daftar yang ditetapkan secara tunggal, single LinkedIn list, daftar yang ingin ditetapkan secara tunggal, and then ada circle LinkedIn list which is daftar terkait sekunder, and then ada double LinkedIn list, yaitu daftar agenda dan daftar ganda terkait, and then ada the portion of list ADT and sorting a portional list, case study, maintaining access, frequency, and link based, first array based, and sequence, and then summary. Jadi ada daftar posisi ADT, menggunakan daftar posisi, studi kasus, mempertahankan frekuensi akses, link based, link array based, sequence, and then ringkasan. Okay, and then masuk pada introduction array-based LinkedIn list. Array-based sequence is an array provides more centralized representation with one large chunk of memory capable of accommodating the reference to many elements. And the limitation of array-based sequence is the length of dynamic array might be longer than the actual number of the elements that is stored. Amortized bounds for operation might be unacceptable in real-time system because insertion and deletion at interior position of an array are expensive. So, jadi untuk array itu menyediakan lebih banyak representasi terpusat dengan satu potongan array besar memori yang mampu menampung referensi ke banyak elemen. Dengan batas urutan besi array, itu panjang array dinamis mungkin lebih panjang dari jumlah sebenarnya dari elemen yang disimpan. Kemudian dari batas diharmonisasi untuk operasi mungkin tidak dapat diterima dalam sistem secara real time, dan bahkan penyisipan dan penghapusan data pada posisi interior array itu cukup mahal. Kemudian dari LinkedIn list is an alternative to array-based sequence which overcome this limitation. Jadi daftar tertaut itu adalah alternatif untuk urutan berbasis array yang mengatasi keterbatasan ini, yang dimana it relies on a more distributed representation, which is lightweight object known as a node is allocated for each element, which is each node maintains a reference to each element and one or more reference to neighboring nodes in order to collectively represent the linear of order of the sequence. And then LinkedIn list has the following limitation, which is elements of a LinkedIn list cannot be efficiently accessed by numeric index k, and we cannot just tell by examining the node if it's seconds, fifth, or 20th node in the list. Jadi daftar tertaut ini bergantung pada banyak representasi terdistribusi, di mana objek ringan yang dikenal sebagai kunci diberikan untuk setiap elemen. Jadi setiap node itu mempertahankan referensi ke elemen dalam satu atau bahkan lebih referensi ke node tetangga untuk secara kolektif mewakili urutan linear dari urutannya. Jadi LinkedIn list itu adalah seperti batasan dari mana elemen daftar tertaut tidak dapat diakses secara efisien dengan indeks numerika. Kemudian kita juga tidak bisa mengatakan hanya dengan memeriksa node jika itu adalah kedua, kelima, 20 dalam node yang daftar. Kemudian dalam single LinkedIn list, a single LinkedIn list it's a simple form is a collection of nodes that collectively form a linear sequence, and each node stores a reference to an object that is element of the sequence as well as the reference to the next node of the list. Okay, and the first and last node of a LinkedIn list are known as the head and tail of the list, respectively, by starting at the head and moving from one from one node to another by following its node's next reference, we can reach the tail of the list by traversing the linked list. We can also identify the tail as the node having none of its next reference, and then because of the next reference is of a node, we can be viewed as a link or pointed to another one by the process of traversing a list. It's also known as link hopping or the pointer hopping. So, jadi untuk sebuah daftar tunggal yang terkait itu dalam bentuk yang paling sederhananya adalah koleksi node yang secara kolektif itu membentuk sebuah urutan linear yang dimana masing-masing kunci itu menyimpan referensi ke objek yang merupakan elemen dari urutannya serta referensi ke node berikutnya dari daftar. Nah, simpul pertama dan terakhir dari daftar terpaut itu dikenal sebagai kepala dan ekor. Nah, dari daftar masing-masing. Nah, ini kepala dan ekor gitu dan memulai dari kepala dengan memulai dari kepala bergerak ke satu node ke node lain dengan mengikuti referensi masing-masing dari node berikutnya. Kemudian juga bisa kita dapat mencapai ekor daftar dengan melintasi daftar tertaut dan kita juga bisa mengidentifikasi ekor berbagai node yang tidak memiliki referensi sebagai referensi berikutnya, karena referensi berikutnya itu dari sebuah node dapat dilihat sebagai link atau pointer ke node lain dengan proses melintasi daftar juga bisa dikenal sebagai lompat tautan atau pointer hopping. Okay. Well, minimally the linked list assistant should we keep first is a reference to the head of the list. Without explaining the reference to the head, there will be no way to locate that node or directly to any others. And then second, an explicit reference to the tail node is not required, but preferred to prevent traversing the rest of the list. And then count of the total number of nodes that comprise the list size is not required, perfect to avoid traversing the list to the count. And then by inserting an element at the head of single linked list, and importantly property of linked list that it does not have a predetermined fixed size, is use space proportionally and it's to its current number of the elements. So when we using a single linked index, we can easily insert an element at the head of the list by steps for inserting an element. By first creating a new node, we can set the element to the new element and then set its next list to refer to the current head, and then set list head to point to a new node. And then by inserting the element at the tail of single linked index, we can create create a new node and then assign its next reference to none, and then set the next reference to the tail to point to this new node, and then update the tail reference itself to this new node. By the algorithm, it's this one is equals node E is to create node assistant storing reference to element E, and then newest dot next equals none, it sets new node next to reference to non-object, and then l.tail.next is equal newest to make an old tail node point to the new node, and then ltail equals newest is set variable to reference the new node, and then l.size equals l.size plus 1 is to increment the node count. Okay, by removing an element from single linked list, by removing an element from the head of a single linked list, it is essentially the reverse operation of inserting a new element at the head. Unfortunately, it's not easy to delete the last node of a single linked list because even if we maintain the tail reference directly to the last node of the list, we must be able to access the node before the last node in order to remove the last node. We cannot reach the node before the tail by following next list from the tail, and the only way to access this node is to start from the head of the list and search all the way through the list, and such a sequence of a link hopping operation which cannot take a longer time. This is operation carried more efficiency in doubly linked list, which is this algorithm is if l dot head is none, then indicate an arrow to this empty L head equals L head next. It's coming to the every next. So make head point next to node or none is decrement of the node count. And then implementing a stack with singly linked in list. This implementation of stack is maintained two variables. First is one is head reference to the node at the head of the list, and then size to keep track of the current number of elements in the stack. By the stack, use a non-public class, just as node is to represent each node which is are pushed or popped into our out of the new stack. So the node object mentions two variables, element to store data, and next to reference to the other node. And this is the coding. We can see this is the node class, and then this timeline, memory usage, initial node field, reference to use element, and then this is reference to the head node, and the top is like the list. This is also the create link and new node. Then this is bypass the current node. This is also the other like for the stack length like 2 0 17 3 50 15 15 and then 10. And then by analyzing of link and stack operation, all of the methods complete in worst case constant time. No amortized analysis is required in this case. So in the space usage is on one end is the current number of the elements in the stack by assist operation as dot push its running time is 1 and is pop. Yeah, I know. And then implementing a query with a signaling in list. This ensure worst case of one time for all operation. This is implementation maintains three instance variable, which is head, tail, size, to avoid traversing the list. Like elements are added and query to the end of the list and remove the query from the front of the list. And then by additional care is to be taken to maintain accurate tail reference. During an query news node, we always becomes the new tail. If there is only one element in the list, it also becomes the new head. On the space usage is linear is the current number of elements is here. We can see well it was the same coding as before, but it now have no head points to the next node, especially case as a query is empty, remove the head had been detailed, and then new node will be adding the new thing, especially case if previously was empty. It will add the reference to the tail node, and then circulating in list. This is circulating in list. So in the previous chapter, we concept of a circle array was implemented using modular arithmetic for advancing an index from the last slot to the first slot of an array. And then in circling in list, the tail of the list use its next reference to the point back to the head of the list. See, this is okay, so they come back. And then in circling in list provides more general model than standard linked in list dataset that are cyclic, that is which is do not have any particular notion of beginning and end. So there's no end, there's no beginning, there's no end because it's circularized. The circularized link-in must be maintained. A reference to particular node to make use of the list is which is current. And then this is a round robin scheduler. Well, a round robin schedule iterates through a collection of elements in a circular fashion and surface each element by performing given action on it, such as circular is used, for example, to fairly allocate a resource that must be shared by collection of the clients. First one is round robin is scheduling often to use allocated silence of CPU time to various applications for running currently on a computer. So in here we can see the query the next element, and then the second service is the next element, and then and query the service element is all shared by one device in the query. And a round robin schedule could be implemented with the general query ADT by repeatedly performing the following step on query Q, which is E equals the Q, the query, and then second surface element E, and then third is Q dot query E. If link in query is used to be uh, implement this, there is an increase overhead of removing a node from front and adding one in at the end. With circular query class, we can actually implement round robin schedule with the following two steps. One is surface element q dot front and then q rotate. Okay, so by implementing a query with a circular inlets, the implementation maintains only two variable is tail, size, and the next reference of the tailing into the head is head itself, tail next, and then circle query class support is an additional rotated method that is remove an element from the front and insert at the end back of the query, and this is achieved by setting the old head as the new tail, like self tag, like here. Okay. Well, I'll be back soon. I was going to the bathroom. What the heck? Can you guys believe this is me? Oh, wait up. It's me. Okay, so it's new. Yes, so this decoding the elements is removed from the head, and by removing the only element, 3 becomes empty, and bypass the old head, the new node will be the new tail node initialized in Struktur, and then the new node points to head, old tail points to new node, and new nodes becomes the tail. old head becomes the new tail, and there's the line and the query by removing element from beginning of the circle query head of the list is here, then you know it is it going to be the tail. This is the tail. No, it's going to be a circle because tail next or head next because the new neck the new head is going to be the tail E, and the current head no to be removed by the old head next and tail next to the old head. Also me. Nomor telepon penting.
Video postingan
Continue. Sunlah, YouTube.
在北京。
My name is Aileen. I am the observer and the guardian of Tessa.
Udah siap belum?
Okay, and the last, and Kui by adding element to the end of the tail, it's of the list. So we adding. This is the head, this current tail node. This is adding back to the tail next, and the node to be added the newest. So the tail next is the newest. It's going to be circleize back, something like that. For me alone, because I'm studying informatic engineering, I will suggest that for this innovation to help address the children's on these problems, we define will make us sort of easiest way to for the communities, for the well, for the government and masyarakat juga. And this one is I guess some oh. Okay, so my laptop because yeah, that's all. I guess my tugas is required 1 hour, so I did many things to get that 1 hour. Hi, I'm Vyola Cecilia Potto. Okay, I'm Vyola Cecilia Potto. Welcome to the Teknik Informatika 2024. So right now I'm fourth semester. Yay! And I'm focusing on academic, especially my tugas. But I really, yeah, whatever. See ya. Thank you for watching. I guess I thought my dosen is required for me from 1 slides to 20 slides of presentation of PPT. This PPT he sends. Okay. Bye bye. Bye bye. Bye bye. Bye bye.